Good afternoon. For those of you that were hoping to see David Lynn, I'm his stand-in today. David wasn't able to make it. My name is Steve Hallett. I'll be talking with you a little bit about Symantec's journey to big data, some of the lessons that we've learned in the last couple of years, and see if this might be of interest to some of you. May not get into the complete technical details. Time is short, but we've got a few people here at the end that will be able to answer some of your questions. So I'm going to start off here with a very, very short video clip. The video clip may appear to be a commercial. It's not a commercial. What I want to do is I want to set it up as one of the reasons why big data is a hard problem for us to solve within Symantec, why it's important to us. And then as the team responsible for building and operating the platform abstraction on top of which we run the commercial products, why we need to be able to build at such a level of scale. So I'll kick off that very, very short video. Symantec, we're glad to be here today. We are a gold member and foundation, and I'm privileged to represent gold members as a board member and on the foundation as well. Our team has done a lot of hard work in the last couple of years. Aside from the commercial that we just saw, it's all about the volume of data. Being able to process data at wire speed on ingest with millisecond latency. It's a challenge that most IT organizations don't know how to handle. How do you handle the ingest at wire speed? How do you also handle the analytics? Analytics, for the most part, being a batch process which looks into the past. How do you marry the past with the present? Analytics, batch processing, near real time. Couple that with real time. Near real time is not real time. They're a little bit different. And then how do you build the capability to actually get to a predictive analytical platform? So being able to handle at scale with the right amount of infrastructure, the right processing power, in the right place at the right time. So the threat landscape that our customers are worried about is getting harder to solve, which means that the amount of data that we have to ingest has already exploded. In the short 2 years that our cloud platform engineering team has been in existence at Symantec, the data explosion within the infrastructure that we operate, which support Symantec products, has exploded by almost 20x. It's a massive amount. So if you think about all the endpoints, the proliferation of endpoints, so all the mobile devices and IoT, right? All the cars that are now connected, all the new appliances that are in your homes that are now connected. The proliferation of endpoints is actually creating a massive explosion in telemetry, and the telemetry is what is so critical. And inside the telemetry are also the signals that we hope to be able to detect about the bad guys that are out there trying to affect us as individuals as well as our customers. So you all know the story. In fact, it's in the news every week. We get news this week, last week, about some major companies that continue to be attacked. So three of the questions that our security teams really want to think about when they are trying to build the capability, the engine to do the analytics is, do we have the data? So is the data available? So what we do is we look at all the frequently used security data. We have to make sure that we identify it and we collect it. Is the data available at scale to be processed? Is it stored within a cold archive? Is it stored within warm storage? Is it within a very, very expensive yet important hot storage where you can access it very, very quickly? Once we have the data, can we analyze the data? What are the analysis engines that are available to us today? What is the value of some of the newer open source technologies versus some of the more legacy and proprietary technologies? And can we provide timely insight? Many of our customers depend upon us to protect them from an event, but also in the middle of an event, which means that timely detection is very, very important. So when we think about security, security is a very, very interesting problem that big data is meant to solve. So within our Symantec cloud, we provide the platform on top of which security analytics are done and a number of other SaaS products. So our internal cloud is a scalable elastic cloud platform built on top of OpenStack and Hadoop and Storm and Kafka and lots of other technologies. It's all open source. We use OpenStack for virtualization, Hadoop, of course, for big data. The Symantec product teams build their products on top of our internal cloud platform, which is built by our cloud platform engineering team. And it is the private cloud, Symantec's private cloud for security products. Right now, our private cloud spans 50 data centers and more than 300 petabytes of storage. Now, this is largely our legacy platform. It's the platform which runs the commercial products today, and it also serves as the source of data ingest into our new platform. So our new platform, which we just started building 2 years ago, is built to be the mechanism to unify and integrate all of Symantec's security products, which includes the big data, analytic applications, as well as services, where you put people behind the analysis. And everything that we're doing, of course, is software defined. So our self-service analytics, this is what we are providing to our customers. Our customers are developers who are building products. Primary purpose is creating and connecting the clusters. We have this notion of authoritative data lake. Is this a term that is widely used and understood? Anybody can raise your hand. Have you heard the term authoritative data lake? Great. So it's a new term to me. I've only been using it and hearing it in the last few months. My team, it tells me that I still need to catch up a little bit. But this notion of about the authoritative data lake now serves as the central authority on, and it's the truth for all the systems of record. Authoritative data lakes, which we'll talk about in just a minute, are proving to be a physics problem and a finance problem that we need to solve, and you're going to have to solve the same thing. It's not just a technology or open source software. It's not just an engineering problem. It's a finance problem, and it's a physics problem. So the capabilities that we deliver to our customers who are product developers is the ability to do a one-click spin-up of an analytics cluster. We use OpenStack VMs for that. This is part of their own developer quota. They have access to admin access to their own cluster. And of course, we automate everything in the way that we also, the automation that we serve to stand up the non-production infrastructure is the same automation that we use to stand up the production infrastructure. So here are some of the use cases that we have defined and that which we have built our platform against. So Hadoop deployed on bare metal. We use Ironic to manage the bare metal. We use Ambari to tune the Hadoop cluster. And on the bare metal, the production instances is where we have the long-lived high-performance production clusters. So we use bare metal for production. We also use Hadoop where we deploy it in OpenStack. This is used for our hundreds of data scientists, literally thousands of developers. They need access to APIs. They don't necessarily need production level performance. So it's for dev test, it's short-lived, makes sense, right? Production's on bare metal, non-production is virtualized. And then we've got a virtual cluster which we use to promote to the bare metal. And we've had successful experimentation. Our challenge today is actually being able to scale this to multi-petabytes. You know, we can do it at hundreds of terabytes, but being able to scale this to a multi-petabyte deployment from virtual to bare metal is something that we're still working with at the moment. And where we're going tomorrow, in fact, it's very much an engineering exercise today, but it's tomorrow's business problem is being able to take our products, our services, and being able to deploy them anywhere. So while we're building a capability for our product developers to build in-house, one of the other charters that our team has is actually being able to then deploy it where needed. So this notion of the hybrid entity, the hybrid cloud, the multi-cloud, being able to deploy simultaneously to your OpenStack private cloud, to your workloads in Amazon and Google and Azure, simultaneously in SoftLayer, simultaneously being able to build that abstraction. That's what we're building today, and that's what we hope to be able to talk about the next time we get together at the next summit, is being able to demonstrate where we've gone from proof of concept to test and actual production. So taking just a little bit of a step back, the reason why big data is important to our team is that we are actually in service to a higher purpose. The higher purpose is actually to mitigate threats to us as individuals, to our families, to our friends, to our companies. That's in the back of our minds in everything that we do. Understanding that the real-time nature of the threat detection, the threat prevention, the threat identification, it's very, very critical, which puts a different emphasis on us as engineers and also puts a different emphasis on us as operators. For those of us that, many of us came from, in my small team, we came from e-commerce companies, we came from payment systems companies, we came from infrastructure companies. A couple of us came from medical and healthcare. It's only the medical and healthcare folks that are actually able to bring a critical sense of urgency in terms of the life or death situation. This isn't necessarily life or death, but it could be, right? In terms of the hacking, the vulnerability, the identity theft and like. The amount of telemetry that we need to be able to identify and process, collect, aggregate, analyze, archive continues to explode. So let's talk just a little bit about some of our design patterns in how we have built and deployed. So we've got this notion of the authoritative data lake. It's big, right? We'll talk in just a minute now. One of our chief architects has given us a requirement for a 100 petabyte authoritative data lake. We'll talk about what that means in just a minute. But today, we've got hundreds of millions of contributing users and sensors. Think about the endpoint which generates the telemetry. Hundreds of millions of endpoints, 3.7 trillion rows of security telemetry. So we know how to do things at scale, but it's bigger than this. We manage over 7 billion unique file, URL, and IP classifications. And we ingest 200,000 new rows of security data every second. It has to be a very highly available, robust system. So you got the endpoint sensors, you've got mobile, you've got messaging, you've got IP reputation, URL reputation, IP classification, file reputation, all sorts of indicators of potential threat vectors. All of this telemetry, this data, coming into a centralized repository. So some of the tools we use. This is not an exhaustive list. It's about 60 to 70%. There's still a few more things. But of course, Hadoop forms the core. We've successfully deployed, and we love the way that Yarn has been able to help us do allocation and scheduling. HTTPFS for file storage. We're using Hive and Pig for SQL. Uzi, Storm, Kafka. Very, very interesting experience we had. I want to pause here for just a quick story. We had an exercise about just over a year and a half ago. One of our fellows came to us. He's one of the fellows in the product organizations, and he's operating one of our most mission-critical legacy applications. And he comes to us and he says, Steve, I need your help. I can't continue to scale the legacy application. We've got all these stored procedures and SQL servers, blah, 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 and it isn't able to keep up with the demand. Got an interesting opportunity for you, I understand, and so we didn't have them on our radar at all. It was a product team that we were not talking with. We thought that they might come onto our platform in a couple of years. And this fellow, he's one of our most recognized engineers in the company. He comes to me and he opens up his laptop and he says, hey, Steve, I downloaded, pick your distro of Hadoop. I downloaded Hadoop. I downloaded Storm. I took my Java app, which is running in production. I wanted to see if it would run with Storm and Hadoop. And he showed me what he did in a prototype that took him just a couple of hours. He was able to take a production Java app, run it through just a little bit of tweaking, put it through Storm, run it on HDFS, and he said, Steve, I was amazed. I'm getting an almost production-like experience. I've got a 4-core Mac laptop, and it's running almost as performant with this open source software as my 40-core production cluster. He had one of those aha moments. He was not an open source guy. He had an aha moment. He said, Steve, I took this Java application, I tuned it over the course of 3 or 4 hours. At the end of the day, I was getting a 3x performance increase over production. We're going to get, production is a 40-core cluster. 40 cores of CPU cores versus a 4-core Mac laptop. He said, I was able to get my Mac to run 2 to 3x faster than production with this open source. He said, Steve, here's my proof of concept. Will you help me? This was one of those amazing moments for me. So now I had an aha moment. A customer of ours who wasn't on our roadmap says, I've already done the proof of concept. We don't have to fund anything. Will you help me? You can't ask for a better scenario where the customer is actually coming to you and asking for help. We started, so that was a lunch conversation a year ago in April. A year ago in May, we started coding. I was still buying data centers and hardware. We didn't have all the infrastructure in place, but we started working together. With no code, no blueprint, no backlog, no team, we went from 0 in May to production in December. Hadoop, Storm, Kafka for queuing, OpenStack. 0 to production in 7 months. This was one of the most important lessons that the Symantec product engineering organizations learned along with us who are building the cloud, building and operating the cloud platform, is that we could actually take the OpenStack way of doing coding out in the open, the community-based +1, -1, the way you have conversations, the way you do blueprint designs, the way we do code and code contribution and test coverage and documentation. We took the OpenStack model, brought it in-house, used that as a way to build a new engineering community, and using that as the backdrop, we went from nothing to production in 7 months with a product team that was, at the very, very beginning, they were still thinking in 18-month waterfall segments. So for the product team that was running on top of our platform, this was a massive lesson learned for them. And I think that continues to be one of the biggest wins we had as an engineering organization, was proving to our customers that working together, we could rapidly prototype, rapidly iterate, and get to a mutual place where we both declared success on a production deployment. So on the left-hand side of the screen is one of the legacy platforms. It's one of our security analytics clusters. It has problems with scale and availability today. We continue to get hammered on the cost of proprietary software and the usage of such. And its backlog is hours or days. The latency, the processing latency, it's massive. So if you think about the way applications and data are served in a legacy platform, you bring data in zip files, you unzip, you load, you put it in SQL. It's a serial architecture, and it's very much oriented towards the way we built applications 10 years ago. We've delivered two new capabilities. We've delivered batch analytics as a process. We call it BPaaS, Batch Processing as a Service, which sits as a REST API endpoint on top of our platform as a service. And Stream Processing as a Service, SPaaS. Stream Processing as a Service, another REST service that we built and delivered. And everything from multi-petabyte HDFS for the batch processing, high availability, usage prioritization. We've gone from hours and days to minutes and hours. And remember, when you're doing MapReduce jobs across hundreds of terabytes and petabytes, it still takes time. It still takes time to map the data and reduce the data and bring all the data in on your east-west network. So even going from hours and days to minutes and hours is still a huge win. Stream processing is where we were able to go from batch, which looks into the past. It's very much looking in the rearview mirror. And the stream processing, which is the near real-time engine, and we hope to be able to tune it shortly to be real-time. Now, some of the engineers that if they came in here and spoke to you, they would say that they're real-time. It's not quite real-time, but it's very, very close. In this case, we're using Kafka, Storm, Spark, Elasticsearch, HBase, et cetera, et cetera, et cetera. We love the way that Kafka has actually allowed us to do enterprise queuing with a level of scale and reliability that we weren't able to see with some of the other message queuing technologies that those of us within OpenStack are familiar with. We're talking about sub-second response time on the ingest latency, which is a massive benefit to our end customers who are looking for that real-time detection. So the analytics pipeline looks a little bit like this, and moving from left to right. We've got data sources which feed data sources. So when you think about multi-step aggregation, you've got raw data coming from multiple different sources. You have to be able to do some level of normalization. You have to be able to do some level of aggregation. You have to be able to do some level of metadata tagging, right? So you got data sources that feed into data sources. Data sources go into stream processing. Stream processing provides the real-time or near real-time. We use Storm, Kafka, and Spark for that. The near real-time then serves as a data ingest into our analytics backend. So we want to collect the data and look at it very, very quickly and see, is there a problem here? Is there a pattern here? Is there something we want to warn our customer about? Are we sensing an anomaly here that we're also seeing with one of our other customers? So one of the benefits is that since we're not siloing our data, we're able to actually provide attribution and context for a problem that may be occurring in one part of the world to another part of the world. And then that initial problem identification, that data then goes into the batch repository, which we then use for large-scale analytics. We look in the past, we look and say, oh, I noticed something interesting. Did that actor show up yesterday? Or was that actor here a week ago? And so we go back and we do some Very, very interesting queries with our data scientists who pressure us to be able to make sure that they have access to all the data all the time. And so try to provide an infrastructure where you have all the data all the time. And they don't want to pay for it. And then it serves into this loop, right? Research, online access, and all the clusters, and powering all this capability is massive, massive infrastructure. Our company is dealing with the challenge of moving from on-premise software development that we ship to a customer and pivoting to software as a service, which means that our financial model changes, because now we have to buy the infrastructure because we're operating this ourselves. We're still learning this. Now, many of you have probably already gone through this exercise. We're still learning what this means to actually pivot from on-premise to SaaS. So here's how we achieved our transformation from hours to seconds. This is, once again, the fellow that I had lunch with about a year and a half ago who said, Steve, I really need your help. I've got some queues, some latency in some of my ingest queues that are approaching a day in backlog. We were getting so much data with an unanticipated, unforecasted, therefore unplanned in terms of infrastructure. We were getting massive increases in spikes in telemetry that we weren't ready for, which created massive congestion in just about every single layer of our stack, which was creating a massive backlog. We had data that was waiting for hours to be analyzed, to be processed. When we went to Hadoop and Storm and Kafka, we have, I think once we've exceeded a second in delay. The rest of the time we're less than a second and we're milliseconds in terms of delay on that initial ingest. It's a night and day technological difference that is actually creating an opportunity for our product teams to think about a new way to aggregate and unify our telemetry. So we improved the time to analyze and deliver the results. Kafka, again, for queuing. It's a powerful engine. We would recommend it strongly. Storm. Now, we could have chosen Spark initially. In fact, we were leaning towards Spark. But one of the interesting things is when our customer came to us and said, Steve, my legacy application written in Java actually works a little bit better with Storm. Can we start with Storm? And my team said, Storm, Spark, we're probably going to use both because they actually do a little bit different things. And you could probably build the use case to have them both running simultaneously. It's not an either or. We found massive out-of-the-box capabilities that allowed the legacy products to move very, very quickly with Storm. So I'm going to just share with you a few screenshots of some of the benefits that we're getting as an operator. So not only are we building this platform, we're their operator of this platform. So many of my team who are in this room here, they're actually DevOps engineers. They're building a net new platform. They're also responsible for running the platform. So Ambari actually gives us an interesting capability to manage the big data clusters at scale. And I was completely surprised with the benefits we're getting from this, but it's pretty cool. So aside from the fact that you can see, this is a snapshot of our prod cluster. You got some interesting data in here. I'm not going to go through it too much. In fact, I'm going to go to the next slide. I'm just going to leave it up here and not go, because if I talk too much about it, I'm going to go into too much detail. But we're looking at, in context, we're looking at some production snapshots of our production infrastructure, and then in just a moment we'll also look at what it looks like from a dev perspective. But the new Ambari views gives us a much more rich and contextual experience as operators of massive infrastructure at scale. And of course, you've got the eye chart, right? We don't have a typical NOC. We don't build, we don't operate, we don't think about the old way of doing things with green lights, waiting to turn to yellow lights, waiting to turn to red lights. But it's important because the alerting mechanisms, the telemetry, the monitoring here actually trigger a DevOps behavior and expectation where the engineers who build the tools and build the infrastructure are actually also building the telemetry to alert them on where we've got critical pinch points in the data processing queues and when they need to come in and look at the health of the system. So a very, very rich, almost out-of-the-box experience that Abari gives us on top of our Hadoop. Very, very quick dashboard construction. This didn't take much time to put up. It was almost layered on top of our data. This here is not production. This is development. I won't point out to you what part of the slide actually says development, but there's actually says development. So this is just looking at how we quantify some of our non-production capacity, our availability. You catch the theme here. We're pretty happy with the out-of-the-box experience and tooling that we've been able to achieve that allows us to move much more quickly and focus our engineering effort on the developer experience rather than the ops function or what used to be a tier 1 or a tier 2 kind of function. It's really interesting when you look at the network layer when you're doing big data. Not only do we have the north-south problem, right, when you're trying to get out of the rack. How do you get the data out of the rack? But it's the east-west problem. How do you pull tens of petabytes that are on multiple racks and you've got your leaf and spine saturated, pulling the data and aggregating it. So it presents a different engineering exercise than what we were expecting and what we typically see in just a pure OpenStack environment. So as we think about a single data plane, as you think about a single control plane, where OpenStack and software-defined networking also govern the bare metal big data analytics, you need to be able to account for the different networking behaviors, different networking profiles, and the different use cases for the compute, the storage, et cetera. See some lots of work here on the data transfer. We love it when we actually saturate our network. We've done some interesting tests with our batch processing where we're just, we've got a 20 gig spine, we're in a couple places a 40 gig spine, and we saturate it completely. So here's our next steps, just sharing with you a little bit of our journey. We're building new products. Well, our companies, we're building new products on top of our new platform, and it's a new unified platform, and we're actually calling our new products Unified Security. Unified Security is one way of thinking about the aggregation of all the insight and intelligence that we have captured in all our various products. So our engineering team is actually building a common and easily extensible way to deliver to our customers who are the product developers. So beyond bare metal and an initial data lake, there's more and more that we actually have to serve up. So you know what happened in the EU, was it 2 weeks ago now? I forget, was it last week or the week before? What happened with data privacy, right? So Safe Harbor was struck down. We were anticipating before 2 weeks ago, but it's becoming even more apparent to our team that we're going to have to deliver multiple in-region, in-country, 10, 20, 30 petabyte data lakes, because we have to be able to prove We have to build it, we have to operate it, but we have to be able to prove that data remains within a particular boundary. Once again, it becomes a little bit more of a finance problem, but it is also a physics problem, because one of the benefits that we provide to our customers is this ability to provide an overlay of insight. So if we see a trend of a bad actor in one part of the world that may be affecting another customer, we have to be able to see that, to identify it, and then correlate that to how it might be affecting another customer without suffering any issues with data privacy, data residency, and the like. So I want to walk you through one of my, I'm going to build this slide, but this is me having a heart attack one day. When a fellow comes up to me and says, Steve, I need a 100 petabyte data lake. So I walked him through this conversation because he wasn't prepared for the outcome here. I want to walk you through the way my head was thinking. So I'm going to call him Joe. He's not Joe, but I'll call him Joe because I've got some people in the room and I don't want them to know who I'm talking about. So I said, Joe, is that 100 petabytes of raw data? He said, yeah. Replication factor of 3, right? Sure. He didn't know what I was talking about because when you're coming from a legacy world on SQL, right, you're not doing replication factors of 3. And he doesn't have experience with Mongo or Cassandra or other types of things. So we're teaching our fellows and our distinguished engineers as they're going through this journey. 100 petabytes replication factor, 300 petabytes. What's the disk overhead? Well, the best practices for Hadoop is you can't use more than 66% of the disk. You've got to keep a third of the disk empty, right? So I'm rounding up here a little bit, but all of a sudden, 100 petabytes becomes 500 petabytes in one data center. What's your availability factor? It's n+1. It's active-active. I need to be able to run simultaneously in 2 locations. Okay, 100 petabytes now becomes an exabyte of disk. And now let's get to the finances. So the way that we were buying disk in the old day, well, yesterday, right? In IT, you go buy some great storage, but it costs about $1 million a petabyte. Now, depending on your discount, you can probably get it down to 900, 8 something. But for purposes of simple math, because I need simple math, let's just say it's $1 million a petabyte. Following me? So it's $1 billion for an exabyte of disk if you buy it the old way. If you're using commodity storage, and we can get commodity storage for about $125,000 a petabyte, and it's a different heat factor, hot, warm, cold, average, right? 125,000. So add it up, it's still $125 million for a single application. This was new to Symantec. This represented a new finance problem, a new engineering problem. This is what we're trying to solve. When we learn about it, we'll share everything. We open source everything we learn, but we're having a lot of fun doing it. What we've learned, Hadoop is built for commodity storage. OpenStack plus Hadoop. It's a powerful combination. Thank you very much. Oh, real quick, I want to introduce some of my folks. So here's our PhD data scientists. They're not in the room today. They really added to all this. And we've got a bunch of folks from our team here. If you have more questions, they're in the room. You'll see them. If you have more technical questions, feel free to ask them. Thank you.